It's another math day here with teacher Jenny. Join me for another discussion, and this time we'll be continuing our discussion pertaining to the sampling distribution, in which right now we will be discussing mean variance standard deviation of the sampling distribution of the sample mean. So I hope you still recall how to get the sample mean of the sampling distribution and how to construct your sampling distribution of the sample mean. So if not, so kindly look for the link on my video on how to construct the sampling distribution of the sample mean. So anyways, let's move on to what we are tasked for today. So we have here construct a sampling distribution of the mean for the set of data below. And this is the same example as what I had in my previous video where I've constructed a sampling distribution. So I'm not going to go through with the step-by-step process here. I'm just going to flash the result of what we had under constructing sampling distribution. Before that one, we had calculated our population mean, in which we derived that from the formula for the population mean, that is equal to the summation of your x divided by your n, which is the population size. So for this one, we've got only 5 size for the population. So we will be plugging that in on the n on the denominator there, and we're adding 86, 89, 92, 95, 98 as your x values. So we have that one here, and our mean will be equal to 92. Now, later on when we compute for the mean of the sampling distribution of the sample mean, you would notice that the value for the population mean here is the same for that value under the mean of the sampling distribution of the sample mean. So later on, you know that one, or you'll see that one. So next, we are going to construct now our sampling distribution, wherein we've got the population data here as 86, 89, 92, 95, and 98. And to give you a refresher in how to construct the distribution there, we are going to write down our combination here of the different samples in which there is no repetition allowed. So we will be having our sample size as n equal to 3. So we'll be combining values based on the population by 3s. So if you have watched the video, you will know that getting the total number of combination there is simply using your NCN. So I hope you can still recall how to get your total combination by utilizing this formula, N taken N. Okay, now what does it mean? This would simply mean that whenever you've got their n factorial, we divide that one with our n minus your n factorial times your n factorial. So all you have to go through is to plug in all the values there, wherein our n is your population size. We've got 5. And of course, we wanted to have our combination as 3 numbers on one combination. So our small letter n is 3. So plugging in that one and using the calculator there, you would get 10 as the value for the total combinations of your data taken 3 values at a time. So here are the following combinations. We have 86, 89, 92. Take note in writing your combination there, you have to arrange it accordingly from least to greatest. So we have there 86, 89, and then 92. So that's the first one. And I hope you recall that when you do the combination or listing down the combination, you will be changing your last digit there or last number, which is 92. You will be changing that one to the next number on the list. So we have here, next combination is 86, 89, and 95. And next one is 86, 89, 98. So I hope you know and I hope you were able to follow through how to get the combination in there. If not, I have also a video for listing down the different combinations. You might wanted to check that out. So kindly look for that one at the bottom part under the details of this video. So next combination, since we're done with the 98, take note 98 is our determinant of when we are to change the next values for the combination. Since we have 98 here, so that means to say we're changing now our second number. So changing 89 to the next number on the list, which is 92. So we have that one as 86, 92, 95. And once you've changed the second number, you will be changing now the last number. So from 95, you go to 98. And of course, you've got 98. That's the determinant. So you go for changing the second number. Second number will be changed from 92 to the next number on the list as 95. So we have 86, 95, and 98. And again, we've got 98. So we will be changing our instead of second number, because 95 is the second to the last on the list, so we cannot have it as 98 because we don't have any other number right after 98. So we will be changing our first number. So first number from 86, we'll be changing that one to the next number on the list, which is 89. So that becomes 89, 92, 95. And we're changing the last number. So 89, 92, 98. Again, 98 is there, so we're changing our second number from 92 to 95. So that means we have 89, 95, 98. And again, we cannot change 95 on the second number there because it's second to the last number on the list. So we're changing our first number. From 89, we go for 92, 92, 95, 98. And that's the last one. So checking up, we've got 10 combinations here. That's the result when we compute for the total number of combinations. So that means to say we're now ready for the sample mean. Sample mean, everybody, is just getting the average of that sample. So first one, we have 86, 89, 92. You add it up and then divide that by 3. That is equal to 89. Next combination, we have 86, 89, 95. Add it up and then divide that by 3. That is equal to 90. 86, 89, 98. Add it up. We divide that by 3. That is equal to 91. And 86, 92, 95. Adding that up and dividing that by 3. That is equal to 91. And next combination, 86, 92, 98. Adding it up and dividing it by 3. That is equal to 92. Next one, we have 86, 95, 98. Dividing that one by 3, that is equal to, sorry on that one, that is equal to 93. And next up, we have 92 for that one. So 89, 92, 95, that is equal to 92 when you divide it by 3. Next, we have 89, 92, 98. Adding that up and dividing that by 3, that is equal to 93. And next one, we have 89, 95, 98. Adding it up and dividing it by 3, that is equal to 94. And lastly, we have 92, 95, 98. Adding it up, dividing that by 3, that is equal to 95. So we're done with our sample mean. So the next one, in what we did last time, we had it written, our sampling distribution. So let me erase this one. Okay. Now, constructing our sampling distribution is for us to list down all those samples that we have sample mean that we have on the first table there. So we have to list it down in an increasing order. So we'll start with the smallest. Smallest is 89. Take note, we do not repeat our sample mean here. So we have to have it unique. Next one is 90. Next one is 91. Next is 92. Next one is 93. And next is 94. And lastly, we've got 95. So that's the sample mean. Now we will be counting how many are those that has 89. how many combinations are there that has a sample mean which is equal to 89. So in that case, we only have one, which is the first combination. So we will be getting its probability. So we will be having our 89 here. That's only one. And then we divide that to how many combinations we have there. So we have 10 combinations. So we have 1/10, or that is now equal to 0.1. Next, we go for 90. We only have 190. So that's again another 0.1 or 1/10. Next, we have 91. There are two 91s. So we have that as 2 over 10. That's equal to 0.2. And next one is 92. We have 1 and 2. That's going to be 2 out of 10. That's 0.2 as well. And we've got 93. We have 1, 2. That's 2 out of 10. We have 0.2. And 94, we only have 1. So that's 1/10. That's 0.1. And next one, we have 95, which is also 0.1. So we have our sampling distribution. Now, next one is for us to look for the mean of the sampling distribution of the sample mean. So how do we look for the mean of the sampling distribution of the sample mean? Now, if you try to recall the topic in which you are looking for the mean, the variance, and the standard deviation of a discrete probability distribution, this is really, really the same thing. This is similar, or it is really with the same process and same formula. So if you try to recall, your formula for finding the mean here is simply in your discrete probability distribution there, this is just equal to mu, or the mean there, which is the summation of your x times p of x. So if you try to recall, this is your also the formula for your mean on the discrete probability distribution. But this time, since this is under the sampling distribution of the sample mean, so we will be annotating that one with the x bar. That will be the symbol for your mean on the sampling distribution of the sample mean. So of course, your x there will be with x bar as well, and so with this one. So, if you were with me on the discussion on the discrete probability distribution, finding its mean, variance, and the standard deviation, I did not follow the formula, but instead I am using the tabular method, in which it also coincides or goes with the formula. Okay? So, if you're not fond of plugging in information or data on a formula, then this might help you. So how to find our mean? You simply have to add one more column, and this column we call that one as x bar times p of x bar. So that is your other column. Now, how do we do this? We are just simply multiplying our first column and second column. So this is more likely easier. So multiplying 89 and 0.1, this is equal to 8.9. 90 times 0.1, that's 9. And 91 times 0.2, this is 18.2. 92.2 multiplied together, that is equal to 18.4. And 93 times 0.2, this is equal to 18.6. And 94 times 0.1, this is 9.4. And 95 times 0.1, this is equal to 9.5. Now, after that one, you will be adding everything under this column, the one that you've added. So you will be adding that up, and that will be automatically the mean. So adding 8.9 plus 9, 18 plus 18.2 plus 18.4 plus 18.6 plus 9.4 plus 9.5, that will be equal to 92, which is our mean of the sampling distribution of the sample mean. So that is how you get your, and as you can see there, your population mean and this mean of the sampling distribution of the sample mean are the same. So I hope you were able to recall that we computed for the population mean a while ago that is equal to 92. And of course, your mean here of the sampling distribution of the sample mean is also equal to 92. So that's one property of your sampling distribution, that your population mean and the mean of the sampling distribution of the sample mean are the same. Okay, so I hope that's clear. Now let's move on to the next one. Okay, next one, we are going to find the variance in the standard deviation of the sampling distribution of the sample mean. Again, I've mentioned under the mean there that this is similar to your discrete probability distribution on finding the mean, variance, and the standard deviation. So since they are the same, the formula also are the same. So we have here your sigma squared. This is equal to the summation of your P of x times your x minus the mean squared. And of course, you have another formula for this one in which you've got there also the summation of your x squared times P of x minus your mean squared. So this is your formula for your variance. And again, since we are dealing with sampling distribution here, we have our symbol for that one is with your subscript as x bar. That signifies that we are looking for the variance of the sample or the sampling distribution of the sample mean. So, and again, we have x bar for this one and that one, and also this one, and also with that one. Now, since we are not so fond of the formula here, we can actually make use of the tabular method again. If you were able to watch my video on the discrete probability, we are solving for our standard deviation and variance using the tabular method. So let's now use our tabular method. So we're adding two columns, in which the two columns here, you will be naming that one as x bar squared, and the other one is our x squared or x bar squared times P of x bar. So that will be our added column. So as the symbol there signifies, we are squaring our sample mean. So squaring that up, we have the first one, 89 squared, that will be equal to 7,921. 90 squared, that's 8,100. 91 squared, that's 8,281. 92 squared, that's 8,464. 93 squared, that's equal to 8,649. 94 squared, that is equal to 8,836. And 95 squared, that's equal to 9,025. So that's the first column. Next, we go for the second added column there. We have x bar squared times P of x bar. So meaning to say, we are multiplying our x squared and the probability in there. So that means we have 0.1 times 7,921. That is equal to 792.1. And 0.1 times 8,100, that will be equal to 810. And 0.2 times 8,281, that will be equal to 1,656.2. And 0.2 times 8,464, that's equal to 1,692.8. And 0.2 times 8,649, that is equal to 1,729.8. And we have 0.1 times 8,836, that is equal to 883.6. 0.1 times 9,025, that is equal to 902.5. So that is the second added column. Now, In order for us to find our variance, we have to add this column, the last column, add it. The result here will all be added. So we have to add 792.1 plus 810 plus 1,656.2 plus 1,692.8 plus 1,729.8 plus 883.6 plus 902.5. That will be equal to 8,467, and then we will be subtracting that by our mean that we've obtained a while ago, which is 92, and we're squaring that out. So that is how we get our variance. So again, once you're done with adding this last column here, we will be subtracting the result by our square of the mean that we've obtained a while ago. And after that one, we try to compute. That will be equal to 3. That will be our variance. So that means to say